Okay, so this is the review presentation for Module 6 right here. So every concept that we have covered in those 4 units in Module 6, you will find on this review. And this is solid. It's good stuff. So let's go through this, check your work, make sure you understand everything, and let me know if you need a little more help. I will go over the review one more time before we test with all of you. All right? So now, look at number 1. Find the slope of segment AB. So segment AB is over here on the right, and you guys are experts at slope. You know that slope is rise over run. So slope of segment AB, slope, the definition is, and this is the graphical definition, rise over run, equals, and what a lot of people like to do is do a slope triangle on their segment, just like that, so they can clearly see the rise and the run. Okay, so 1, 2, 3, 4, 5. Looks like we're rising 6, and we're running 1, 2, 3. So that slope then is 6 over 3, which you can probably simplify 6 over 3, because doesn't 6 over 3 reduce to 2 over 1? And I'd write it like that personally, but if you wrote the 6 over 3, I could give you most of the credit right there. And then of course you can simplify 2 over 1, because 2 divided by 1 is just a 2. But if you look, you check this here too. If I go up 2 and over 1, I'd end up right there. And if I did it again, up 2 and over 1, there I am. And do that one more time, and there I am on point B. So the slope of that segment AB is 2 over 1, or just a 2. And there you go, your first question. Now, find the slope of a line that is perpendicular to segment AB. Now you guys remember your definition of perpendicular slopes. It's the negative reciprocal stuff. So, M sub 1 is perpendicular to M sub 2 means if M sub 1 equals A over B, then M sub 2 would have to be the negative reciprocal of A over B, which is a negative, negative reciprocal right there, B over A. Awesome. All right. So, well, let's look at our slope. Our slope was 2 over 1, so the negative reciprocal of 2 over 1 would be, well, 2 over 1 is positive, so this has to be negative, and the reciprocal of 2 over 1 is 1 over 2. So there's your answer to number 2. Find the slope, and then find a slope perpendicular to that slope. Now, find the distance between A and B, or the length of segment AB. So they're asking you to find this length right here. And I hope you see that we have a right triangle in this diagram already, so we probably just want to use Pythagorean theorem. And you see how I set up the right triangle? The 90-degree angle, and C is the hypotenuse, the side that is opposite that 90-degree angle. All right, and you guys should know Pythagorean theorem is A squared plus B squared equals C squared. All right, so let's plug in what we know. So the A and the B are the legs of the right triangle, and order does not matter here. So I probably did A as a 6. So if I go 6 squared, I'm going to get a 36. Oh, I wrote it like this. So 6 squared plus, and then the other leg squared would be a 3 squared, and that has to equal our C squared. Now let's go ahead and do those squares. So 6 to the second power would be 6 times 6, or 36. 3 to the second power would be 3 times 3, or 9. So 36 plus 9 equals C squared. And what's 36 plus 9? That's 45. So 45 equals C squared. And now to solve for C, you have to undo this square with a square root. So you're going to take the square root of both sides. So on the left, I have the square root of 45. And on the right, I have the square root of C squared. Okay? And of course, the reason we did that is I can't simplify the square root of 45. I'm just going to leave that alone. But if I square root a C squared, I can drop the square, and that just gives me C. So the exact distance from A to B is the square root of 45. Now, number 4. And this brings some stuff from first semester back to us. So watch this carefully. Write the equation of the line that is the perpendicular bisector of segment AB. So you got to understand what it means to be a perpendicular bisector, okay? That means I need a line that goes through the middle of segment AB, exactly the middle, and you can almost see it right here. I think that's going to be this point about right there, but I'm going to show you how to find the midpoint too, and it's perpendicular, so you can do this. Okay, so what I'm going to use, since I'm going to have a point and a slope, I'm going to use my old point-slope form of a line. All right, and later on we'll do something like this and we'll use slope-intercept. So remember this, y minus y sub 1 equals m times the quantity x minus x sub 1. Well, let's find that midpoint, and again, here's how you find a midpoint. Here's a simple formula right here. The midpoint of any segment is the average of your x coordinates, comma, the average of your y coordinates. All right, and we write that in general. We say x sub 1 plus x sub 2 divided by 2, and then over here it's y sub 1 plus y sub 2 divided by 2. And with this I can easily see my midpoint. So my midpoint is going to be, well, if I average my x coordinates, let's write down the coordinates of each of these points right here. The A has an x coordinate of 2 and a y coordinate of -3. And the B has an x coordinate of 1, 2, 3, 4, 5, and a y coordinate of +3. There you go. Now, x sub 1, x sub 2. That would be 2 plus 5 is 7, and if I take 7 and divide by 2, I'm going to get a 3.5. 3.5 is my x coordinate. And now, let's take the average of y sub 1 and y sub 2, which is going to be -3 plus 3 is 0, and 0 divided by 2 is a 0. So that is the midpoint, 3.50, which is right there. And does that look perfect? It looks perfect to me. So now you have a point, and you also already know what a perpendicular to segment AB, the slope would have to be. We did that earlier. It's got to be a -1/2. Right there. So I'm going to use this form right here, and here's what I'm going to do. Now watch, I'm going to graph it too. So if I start right here and I drop 1 and I run 1, 2, there we go, right there. And does that look perpendicular to you? Yes, it does. Okay, so now let's go. Y minus y sub 1. That's the y coordinate of this point right here, which we just said was a 0, equals, and we just said our slope was that -1/2, quantity x minus x sub 1, and the x coordinate of that midpoint right there is the 3.5. And there's the equation right there. That is so cool. Okay, let's go off to, let's talk about some transformations now. Oh, this is cool. Using the diagram below to match the image/pre-image listed on the left with the transformation listed on the right. So they're going to give you image and pre-image and then transformations, and you decide which one works. So for number 5, the pre-image is shape 1 right there, and the image is shape 2, which is down here. So my first thought is this. Does this look like our triangle rotated? Yeah, so I think I'm going to picture rotations first. So I see that and I think rotations. So I'm going to look at my transformations and I'm looking for the rotations. I got one here, I got one here, and I have one right here. And those are all rotations about the point 0, 0, which is the origin. So here's my point of rotation right there. Now picture B to the point of rotation right there, and then B prime is right here. So let's label that B prime. Now you guys can tell me, how many degrees does this look? That looks like 90 degrees to me. All right, and here's a direction too, and it looks like we're going counterclockwise. So I'm looking for a rotation about the point 0, 0, 90 degrees counterclockwise. Rotate 90 degrees counterclockwise about 0, 0. It looks like B, that first one right there. Yeah, so the answer to number 5 is this B right here. So I'm going to put a B right next to it too. Okay, let's look at 6 then. The pre-image now is shape 2, and the image is shape 3. So this does not look like a rotation. This one looks like we reflected over a diagonal line right there. So I'm thinking reflection, all right? And now I look over here, A is a reflection, C is a reflection. So I know already that it's A or C. Now, did I reflect over x equals 0? And x equals 0 is the vertical line where every x coordinate is 0. That would be the y-axis. Does it look like we just reflected over that? No, that's not a perpendicular bisector to that segment, is it? So that one doesn't work. So what's y equals negative x? Well, some of you see it right now, and some of you really need to think of your slope-intercept stuff right here. So y equals negative x. Now remember, y equals mx plus b. I've told you guys this before. The most important formula in all of mathematics. So I'm going to take this y equals negative x and put it more into this form, mx plus b. So if my slope is a negative, that's equivalent to negative 1. So I'm going to think of that as a negative 1 over 1, rising negative 1, running 1. And then b, well, there is no b there, so that's plus 0. So that means I have a line with a y-intercept of 0 right there, and a slope of, I rise negative 1 and I run 1 right there. And then I break out my ruler, and that is the graph of y equals negative x right there. And that does look like the perpendicular bisector of BB prime. I see 90-degree angle right there, and this side is the same distance as this side. So that's it. So the answer to number 6 would have to be the reflection over the line y equals negative x. There it is. So I'm going to put a C there too. And you can use the arrows like I did, or just bring the letters over, whatever works for you. Now, number 7, the pre-image is 4, shape 4 right down here, and the image is shape 2. All right, so to get from this picture to this picture, oh, again, it looks like what? Are we rotating again? I think so. Looks like a rotation to me. All right. And we have to rotate about the origin, 0, 0. And then I'm picturing the image of B would be right there. My B prime would be right there. All right. So now look at this rotation. Kind of picture it. All right. And what is this angle right there in direction? It looks like we're rotating clockwise. And does that look like 90 degrees to you? So I would say that to get from shape 4 to shape 2, we're going to rotate 90 degrees clockwise about the point 0, 0. Look at this. Rotate 90 degrees clockwise about the point 0, 0. The answer to 7 is that E right there. Okay? Now, 2 more to go. 8, the pre-image. We're going shape 1 to shape 4. Shape 1 to shape 4. Okay. Now, is that going to be a reflection or a rotation? I don't know. It looks to me like we're rotating, you guys. All right? Because let's kind of picture it. Am I rotating just 180 degrees? I think so. So, and look at, here's the only rotation right there, so I think it has to be D, but let's double check. Okay, we're rotating about the point 0, 0, and we're rotating 180 degrees. So let's go ahead and put this segment right here. And I went down 2 and over 1 and down 2 and over 1 again. That looks really good to me. So 180 degrees, it doesn't matter if we go counterclockwise or clockwise here. All right, so I'm going to picture this clockwise. So it looks to me like we have a rotation of 180 degrees about the point 0, 0, and clockwise or counterclockwise does not matter with 180, and that's why they didn't give you a direction right there. So we are good. The answer to 8 is D. And then finally, number 9. The pre-image is shape 1, and the image is shape 3. Oh, so does it look to you like we're reflecting over this line x equals 0 or the y-axis? that looks like a perfect reflection to me. And that's all we have left. But let's double check everything here. So if I reflect point A over that line x equals 0, wouldn't it end up right here? Oh, I did the B first, and the A prime would be up there, and I only did the 1. So anyway, yeah, that looks like a perfect reflection. Look at how my anchor point B reflected over the line x equals 0 and ended up right there perfectly. So the answer to number 9 is A. And there you have it. And again, you can write the letters next to your numbers like I did, or just do the arrows, whatever works best for you. I think most of my students typically on a matching problem like this, they do the arrows and they write the letters, which is cool. Okay, I'm going to break now and check on my class, and then we will finish up this video in a moment. Let's start this now. So for number 10 and number 11, we're going to perform the requested transformations. Make sure to label A prime and B prime. So on number 10, they gave you this graph of segment AB right here, and all they're doing is asking you to reflect this segment over the vertical line x equals 2. So the first thing you want to do is graph your line of reflection, and you guys know x equals 2 is a vertical line where every x coordinate is 2. So that would be right here. Okay? Now, if I reflect these 2 points over that line, well, check it out. And I don't know which one I did first, but do you agree that the B is 1 unit from the line of reflection, and I'd have to go 1 more? So B prime would end up right there. Let's see if I did the B prime first. I did. So that's B prime. All right. Now look at the A. How far is A? 1, 2, 3, 4, 5 units. So we got to go 5 units again. 1, 2, 3, 4, 5 units right there. And that's my A prime. And there's my segment right there. So A prime, B prime is the reflection of AB over the line x equals 2. And that's perfect. Now, 11. We're going to rotate 90 degrees clockwise about the point -3, 1. So first let's plot that point of rotation. -3, +1. Oh, that's point A right there. Oh yeah, and I did a little bit of this stuff going on there so you can see that. Okay. Anyway, there's my point of rotation. Okay. So if I'm going to go 90 degrees clockwise, I'm going to be going this way. And clockwise 90 degrees, well, I like 90 degrees because I can figure out my slope. All right. So I'm going to use the negative reciprocal stuff here. So there's my A or A prime right there. And now remember your rule for slopes of perpendiculars. M sub 1 is perpendicular to M sub 2. What that means is if M sub 1 is A over B, rising A and running B, then a perpendicular would be, M sub 2 would be, well, there's no negative, so I'm going to put a negative. And then the reciprocal of A over B, B over A. So I need the slope of this segment so I could find the negative reciprocal. Yeah. Okay. So what's the slope of segment AB? Well, I'm rising 1, 2, 3, and I'm running 1, 2, 3, 4. All right. So then the slope of A prime, B prime, which would be a negative reciprocal. This is positive, so I need a negative. And then what's the reciprocal of 3 over 4? 4 over 3. So I go to my point of rotation, and I'm going to rise -4. 1, 2, 3, 4. And I'm going to run +3. 1, 2, 3. And there it is right there. And that will give me my B prime. And look at this rotation and make sure you agree with it. So does this look like we took segment AB and we rotated 90 degrees and B ended up right there at B prime? That's perfect. By the way, that segment is congruent to that segment too. Okay, now number 12. Now we're going to rotate over the line y equals -x. Well, we saw that line y equals -x earlier, so let's graph that again. And again, I'm thinking of it like this so you guys can clearly see the slope-intercept. The y-intercept is 0. And the slope is -1 over +1. So I'm going to rise -1 and run 1. And then I get my ruler out. And there is the line that we are reflecting over. Okay? Now, let's reflect A and B. And you guys know they're going to end up over here and over here. But let's do this perfectly, because this line we're reflecting over has to be the perpendicular bisectors of the segments we're going to set up between pre-image and image. All right. So, aren't my segments going to have a slope that would be the negative reciprocal of -1 over 1? So the slope of a perpendicular, if this is negative, this one's going to be positive. And then 1 over 1, well, the reciprocal of 1 over 1 is still 1 over 1. So that means I'm going to rise 1 and run 1, go there. But that's going the wrong way. So could I do this like this? Go down 1 and to the left like that? And I did that several times here. Down 1. I did it twice. Did it 3 times right there. So that would have to be A prime right there. And there's my segment. Now look at this carefully. That looks definitely like 90 degrees. And look at this distance right here. 1 diagonal, 1.5 diagonals, and then from here to here is also 1.5 diagonals. So those two are congruent. Now let's do the same slope with the B. So I'm going to go down 1 over 1, down 1 over 1, and do that 2 more times. Down 1 over 1, down 1 over 1, and that point right there is my B prime. Draw your segment, and again, 90 degrees. Why, yes. And this distance is going to be the same as that distance. So this is the perfect reflection of segment AB over the line y equals -x right there. All right. Now number 13. Draw the line of reflection that maps P onto P prime. So we need the line of reflection. Then write its equation. So we're going to need a midpoint of a segment here. And then we're going to need a slope. Okay? So midpoint. Well, we found midpoint earlier, and we got a formula for that. This one you might be able to see pretty easy too. Looks like I'm going 1, 2, 3, 2. 1, 2, 3, 2. The midpoint is going to be exactly this point right there, because I've got a slope of, again, what's my slope? I'm rising 3 and I'm running 2. And if I do that again, I'm right there at P prime. So that's got to be the midpoint right there. So now I have a point and a slope, so I'm ready to come up with my equation. So this midpoint, the x is 0 and the y is -1. All right, and that happens to be a y-intercept. So if I have a y-intercept and a slope, I'm going to use y equals mx plus b. All right, and now think about this. So this line of reflection has to be perpendicular here, so I need negative reciprocal of 3 over 2. That's going to be -2 over 3. So let's finish this. So I went down 2 and over 3. And there's my line of reflection right there. Does that look legit to you? It certainly does to me. So let's come up with this equation. So y equals, and the slope of this red line of reflection right there is that -2/3 times x. And what's the y-intercept? -1. And there it is, 13. Wow, so that was it, and that's the review. I hope you guys enjoyed it, and we will go over this together in class, and let's get all of our questions answered. I hope you enjoyed that as much as I did. Everybody have a great day.